Now, the other type of question that we can get with straight lines is to solve variables. So here we are given points A and B where the y value is k, and we are asked to find k if the line AB is parallel to the line 2y minus x equal to 6. So what we know about parallel lines is that their gradients are equal. So I can find the gradient of line AB, and by rewriting this equation in standard form, I can find the gradient of this line. So first we would say 2y minus x equals to 6, and I would rewrite it in standard form. So it's x plus 6. Standard form means to write it in the form of y is equals to mx plus c. So I want to isolate the y on the left. So continuing with this formula, I would need to divide everywhere by 2 in order to find y alone. Therefore, the gradient of the line that is given to us is equals to a half. Remember, in standard form, y is equals to mx plus c. The gradient is the coefficient of x. So in this example, the gradient is a half. I can also find the gradient of line AB. That's y of b minus y of a divided by x of b minus the x of a. That is k minus 2 over 1 minus 3. And if I simplify, that is k minus 2 over 4. Now I know that the gradient of AB is equal to the gradient of the line because AB was given as parallel to that line. Parallel lines' gradients are equal. Therefore, k minus 2 over 4 is equal to a half. So k minus 2 is 4 times a half, which is 2. Therefore, k is 2 plus 2, which I move over. So k is equal to 4. Okay, let's look at another example. So here we are given the points A and B as we had them before, and we are asked to find k if AB is perpendicular to this line. Now remember, when lines are perpendicular, the products of their gradients would be equal to -1. So first, let's rewrite this line in standard form. So I have -3y minus 2x plus 9 equal to 0. I move the 2x over and the 9, and I have -3y on the left. Then I divide everywhere by -3. So y is equals to 2 over -3x plus 3. 9 divided by -3 becomes plus 3. Therefore, the gradient of the line is equals to -2/3. Remember, in standard form, y is equals to mx plus c, and the coefficient in front of the x is the gradient of the line. Now we can find the gradient of line AB. So it's the difference of y's over the difference of x's. So the gradient of line AB is k minus 2 over 4. Now because these lines are perpendicular, k minus 2 over 4 times -2 over 3 is equal to -1. So this would mean -2 k minus 2 in the numerator. So I multiply -2 with k minus 2. Notice I'm keeping it as a bracket. And 4 multiplied with 3 in the denominator. Therefore I have the denominator as 12. Now, in order to remove the denominator, I multiply the right-hand side by 12. So that becomes negative 12 on the right and negative 2 times k minus 2 on the left. Then I divide everywhere by negative 2. So it's negative 12 divided by negative 2, which becomes 6. So k minus 2 is equal to 6. And then in order to solve k, I transpose the 2. So therefore, k is equal to 8. In this example, we are given the point A, and we want to find the equation of a line through point A that is parallel to the line y is equals to negative 4x plus 11. Now this line is already in standard form, so I can see that the gradient of that line is equals to negative 4. So the coefficient in front of x is the gradient of the line. And now I want to find the equation of another line running through the point A that is parallel to this line. So what we know about parallel lines is that their gradients are equal. And if I use a straight line formula, which I had at the start, I have y minus y1 equals to the gradient x minus x1. Now, our x1 value would be the x value of A, and our y1 value would be the y value of A. So that would be y minus 5 equals to the gradient of negative 4, because the lines are parallel, they have the same gradient, x minus 3. Then I multiply out, that's negative 4x plus 12, and on the left y minus 5, and then I transpose the negative 5. Therefore, the equation of this line is negative 4x plus 17. So you can see that these two lines would be parallel to each other because they both have the same gradient, but they have different y-intercepts. So if we represent these two lines graphically, we would see that y is equal to negative 4x plus 11 runs through the y-intercept of 11. And the equation of the line that we found runs parallel to that line, but this time it will go through the point A, 3 and 5. So this line is y is equal to negative 4x plus 17. In this example, we have the exact same coordinate and the exact same equation of a line, and we want to find the equation of a line through A perpendicular to that line. So only one word changed from the previous question. Here we had the line parallel, and now it's perpendicular. So what we know is that from the equation of this line, its gradient is equal to negative 4. And the gradient of the new line, which we need to find, times the gradient of the line that is given, must be equal to negative 1 if they are perpendicular to each other. So now I want to find the gradient of the new line. So I substitute the negative 4 in there, and then I find that the gradient of the new line is equals to a quarter. So it's negative 1 divided by negative 4, and that becomes 1/4. Now, if I use the straight line formula, which I have on my formula sheet in grade 12, I have the gradient now is not negative 4, but the line must be perpendicular. So this gradient is 1/4. And my x1 and y1 values, x1 is equals to 3, y1 is equal to 5, so it's y minus 5, x minus 3. Then I multiply out, so that is a quarter x minus 3/4. And on the left, I have y minus 5. Then I transpose the 5, so it becomes plus 5 on the left. Therefore, y is equals to a quarter x plus 4 1/4. So if I plot them on a Cartesian plane, I would find that y is equals to negative 4x plus 11 is perpendicular to y equals to a quarter x plus 4/4. And this line runs through the point with the coordinates of 3 and 5.